They had a human applicant. Torin Ash, Salvage Corps, Outer Rim posting. The review board would evaluate him. Good, let them. The Interstellar Engineering Consortium had been accepting applications for its Advanced Propulsion Design Fellowship for 42 years. In that time, it had produced 318 certified propulsion architects. Their designs powered vessels across 14 active trade corridors and 3 military patrol networks. The fellowship did not select candidates on the basis of origin. It selected them on the basis of demonstrated technical capability, verified through a 3-stage assessment process that had remained largely unchanged since the program's founding. What the assessment process could not account for was the culture that had grown around it. 42 years was long enough for an institution to develop a set of assumptions that no longer needed to be stated out loud to carry weight. Which species had historically produced the strongest candidates? Which academic pipelines were considered legitimate feeders into the program? Which posting backgrounds suggested a candidate was serious, and which suggested they were applying out of optimism rather than genuine qualification? These assumptions lived in the way reviewers phrased their questions, in the way other fellows discussed the new cohort, in the informal conversations that happened before and after the formal sessions. Humans had been operating within consortium-affiliated networks for 26 years. Human candidates had been applying to the fellowship for 11. In 11 years, 4 humans had been accepted. 2 had completed the program. The current cohort had 1. His name was Torin Ash. He was 31 years old from a salvage and repair station on the outer edge of the Halveth corridor, and he had arrived at the fellowship's primary facility on Keleth Station with a portfolio that the intake coordinator had reviewed 3 times before forwarding it up the chain because the scope of work documented inside it seemed inconsistent with the candidate's listed institutional affiliations, or rather his lack of them. Torin had not come through any of the recognized pre-fellowship programs. He had not been sponsored by a university engineering department or a major shipyard consortium. He had spent the previous 9 years working Salvage Corps postings in the Outer Rim, and the work he had documented in his application portfolio had been done in the field, under operational conditions, without a laboratory, and frequently without a complete set of tools. The intake coordinator had flagged the portfolio for authentication review. The review came back confirmed. Every project documented was real. Every system Torin claimed to have designed, repaired, or rebuilt had operational records attached. The intake coordinator had noted in her forwarding message that several of the documented solutions were approaches she had not previously encountered in the literature. Torin had not mentioned any of this when he arrived. He found his assigned workspace, attended the orientation sessions, and moved through the first weeks of the fellowship with the specific quality of someone who was focused on the work itself rather than on the social landscape surrounding the work. He was not unfriendly. He was not withdrawn. He simply appeared to have made a prior decision about where his attention was going to go, and the informal hierarchies and status negotiations of the cohort were not where he had decided to put it. The cohort noticed him anyway. This was partly because of his background, which was well outside the pattern of what the fellowship usually produced, and partly because of the way he engaged with the technical material, which was difficult to categorize. He asked questions that occasionally made the senior fellows pause before answering, not because the questions were disruptive, but because they came from an angle that suggested a different underlying model of the problem. He produced solutions that worked, but that did not always look the way solutions were expected to look. And he had a quality, in workshop sessions, of listening to other people's explanations with an attention that was either very respectful or slightly unsettling, depending on your perspective, because it was the attention of someone who was checking what they heard against a very large internal archive. The challenge came in the 6th week. The fellowship ran a weekly technical review session. 12 fellows gathered around a presentation table in the main workshop, rotating through presentations of current project work and receiving critique from the group. The session was formally structured and informally competitive. Strong presentations built reputation within the cohort. Weak ones left marks that took time to recover from. The format rewarded confidence, fluency with the standard technical vocabulary, and the ability to defend methodology under pointed questioning. Senior fellow Ronik Dov was 4th year, ranked first in the cohort on all formal assessments, and had a reputation for asking the kind of questions in review sessions that were precise enough to be legitimate, but targeted enough to serve a social function beyond the technical one. He was not, by any standard measure, a cruel person. He was a person who had learned that demonstrating his own precision and the limits of others' precision simultaneously was efficient, and he had become good enough at it that the behavior had been rewarded often enough to continue. Torin was presenting his current project work, a redesigned fuel distribution architecture for mid-range courier vessels, specifically addressing efficiency losses in high-variance trajectory profiles. The design was unconventional in its approach to load balancing. It worked from a set of principles that were correct, but that had been derived from operational field observation, rather than from the standard simulation frameworks the Fellowship used. Torin presented it clearly. He did not over-explain. He put the schematics on the display, walked through the logic, and stopped. Dov let the silence sit for a moment in the way that certain people let silences sit when they have already decided what they are going to say. "Interesting approach," Dov said, in the tone of someone for whom interesting was doing significant work. "For a field repair, can I ask, what simulation suite did you use to validate the load distribution model?" Torin looked at him. "I didn't use a simulation suite." The room shifted slightly, not dramatically. Just the small postural adjustments of people recalibrating their attention. "The validation came from operational data," Torin continued. 14 vessels, 16 months of trajectory logs. The distribution patterns I'm modeling are derived from observed performance across actual high-variance profiles. "Operational data from salvage postings," Dov said. "Not a question, a categorization." "Operational data from vessels that were actively failing," Torin said, with the same flat steadiness he'd had since the beginning. "Under conditions that simulation suites generally don't model because they assume the systems are functioning within design parameters. Most of the interesting load behavior happens when they're not." There was a beat. "The Fellowship's validation standard," Dov said, "requires simulation confirmation before field testing. That's a methodology requirement, not a preference." "I know what the requirement is," Torin said. "I'm presenting field-derived work with the intent to run the simulation confirmation during this cycle. I'm noting that the design was developed from real-world failure data because I think that context is relevant to understanding why the load model looks the way it does. If it doesn't look like what you'd get from a simulation-first approach, that's because it wasn't built from one. It was built from watching 14 couriers struggle with the exact problem I'm solving." Dov's expression had the quality of someone who had prepared for a particular kind of response and had received a different one. He shifted. "The concern," he said, "with field-derived methodology in a program like this one is reproducibility. You can't scale a design approach that depends on access to specific operational conditions that most engineers in this program haven't had and won't have. The point of a standardized simulation framework is that everyone can use it. It creates a common language." Several fellows nodded, the nod of people for whom the argument was familiar and comfortable. "That's a real concern," Torin said. "The common language is valuable. I'm not arguing against the framework." He looked at the schematic on the display. "I'm saying the framework has a gap. It models systems functioning within tolerances. It doesn't model the failure cascade behavior that you see in vessels operating past those tolerances, which is where most of the interesting load distribution problems actually live. If you only design from simulation, you get designs that work well in the conditions the simulation models. You get surprises in the ones it doesn't." The room was quiet in a different way than it had been quiet before. Dov said, "That's a significant claim about the limitations of a validation methodology that has been the field standard for 30 years. "Yes," Torin said simply. The silence this time was longer, and it had a different texture. Workshop Director Solon Vereth had been sitting at the far end of the table since the session began. She had not said anything since Torin started his presentation. She had a way of running review sessions where she let the room generate its own dynamics before she intervened, because she had found, over the years, that the most useful information about a cohort came from watching how they engage with each other, rather than from watching how they performed for her. She had read Torin's intake portfolio in full. She had read it twice, in fact, because the first read had produced an assessment that she wanted to check against the second. She had been in this position long enough to know that the candidates whose portfolios required a second read were either significantly overqualified or significantly misrepresenting themselves, and the authentication review had told her which category this was. She had been waiting for this moment since the third week. Vereth leaned forward slightly and pressed the display control at her end of the table. The schematic Torin had been presenting was replaced by a different file. "Since we're discussing validation methodology," Vereth said to the room, and specifically the question of what simulation frameworks do and don't capture, it seems like a productive moment to look at some operational case studies. She looked at the cohort. Torin's portfolio was flagged during intake for authentication review. I've had the full documentation available since his arrival. Given what we've been discussing, I think reviewing it together is relevant to the methodology question Dov raised, which is actually a good question. The answer to it is more complicated than either position taken here today. She pressed the control again. What followed was not a presentation in the conventional sense. It was a documentation review. 14 cases pulled from the portfolio, each one an operational record of a propulsion or distribution system failure that Torin had encountered during his salvage core postings, and the solution he had designed and implemented in response. Vareth walked through them methodically. The first case, a mid-range freighter in the outer Halveth corridor, fuel distribution failure in the third stage of a multi-point trajectory, 6 days from the nearest service station, crew of 9. The design parameters of the original system had assumed clean fuel composition and standard corridor conditions. Neither had applied. Torin had rebuilt the distribution architecture on-site using components cannibalized from the cargo manifest, working from a hand-drawn schematic on the inside of a cargo panel. The vessel had completed its trajectory. The modified system had performed within 4% of design efficiency for the remaining 6 days. Vareth noted without emphasis that the specific failure mode Torin had addressed in that case was not represented in the standard simulation suite because the suite assumed fuel composition within coalition standard tolerances. The freighter had been running on a mixed fuel blend that was common in the outer rim, but that the simulation framework had never been updated to model. The room listened. The second case was a patrol vessel, salvage core contract, structural compromise in the drive housing during a high-G evasion maneuver. Not a fuel system problem. A materials stress problem that had propagated into the propulsion architecture in a way that the original designers had not modeled because the maneuver profile that caused it exceeded the vessel's design specifications. Torin had stabilized the drive housing using a bracing configuration derived from stress distribution principles he had applied to a different system type. Hull reinforcement, not propulsion architecture, adapting the logic across domains in real time. Vareth noted that the adaptation itself had been documented and submitted to the Consortium technical journal. It had been published. She named the issue. A fellow near the middle of the table looked up from the display with an expression that suggested he was recalibrating something. By the fifth case, the room had the specific silence of people who were watching something and simultaneously adjusting their understanding of what they had been watching for the previous 6 weeks. Dov was not taking notes. He was looking at the display with an expression that was not quite any single identifiable thing, but that had, in its general character, the quality of someone who had asked a precise question and was in the process of discovering that the precision had been aimed at the wrong target. The cases continued. A derelict transport, skeleton crew, catastrophic failure in the waste heat management system that had cascaded into the primary propulsion loop. The recovery took 11 days. The design Torin had implemented to manage the thermal cascade was, Vareth noted, a novel approach to a problem that had a standard solution in the literature, and his approach was demonstrably more efficient under the specific operating conditions of the failure. Conditions that, again, the standard simulation suite did not model because they represented a system in active distress rather than a system in normal operation. She paused on that point. The framework assumption, Vareth said to the room, without looking at Dov specifically, is that we design for normal operation and test for failure at the margins. What Torin's field record documents is a different approach, designing from failure and working backward to a system that behaves well both in failure and in normal operation. The two approaches produce different solutions. Neither is always superior. But the second approach produces solutions that the first approach does not, because it operates from a different model of what the system needs to survive. She looked at the cohort. The simulation framework gap that was mentioned is real. I've known about it for 8 years. The gap exists because the committee responsible for updating the framework has not had consistent access to operational data from outer rim posting conditions. That data exists. We have not been using it systematically. She pressed the control and cleared the display. That is a methodology problem. It is not a problem with the candidate who identified it. The room was quiet. Vareth looked at Dov with the precise, neutral expression of a person who was making a point without requiring it to be acknowledged out loud. The review question Dov raised, she said, about reproducibility and common language, that question stands and deserves a serious answer. Torin, I'd like you to bring a written proposal to next week's session. How would you translate the operational data you've been working from into a form that could be incorporated into the simulation framework? Not to replace the existing approach, to extend it. Torin looked at her for a moment. I have most of it already written. Vareth's expression did not change, but something moved in it. The quality of someone who had expected this, and was still, despite the expectation, mildly satisfied to have it confirmed. Bring the full version, she said. The session ended. Fellows moved toward the door in ones and twos. Several slowed near Torin's end of the table without finding a reason to stop entirely. The specific physical hesitation of people who had updated their assessment of something and had not yet figured out what to do with the new version. Dov was the last fellow to leave. He stood at the door in the posture of someone who had come to a session expecting one thing, and had spent the last 90 minutes receiving something else. His expression was not hostile. It was the expression of a person doing a calculation that had more variables in it than he had started with. He looked at the blank display where the case studies had been. The outer rim failure data, he said to the room generally, as though completing a thought he had started silently. How long has that gap been documented? 8 years, Vareth said, from the end of the table where she was still sitting. Dov absorbed this. Then he left. Torin began gathering his materials, the original schematic still on the secondary display, his notes, the worn-edged field manual he had carried since his second posting, which he set on top of the stack with the specific care of someone for whom the object had a particular history. He looked at Vareth, who was still at the table, writing something in the session assessment log. You had the portfolio available since week 3, Torin said. It was not a question. Since intake, Vareth said. I was waiting for the right discussion to come up. Torin looked at her for a moment. His expression had the quality of someone processing the difference between something that had happened to them and something that had been arranged. Then something settled in it. Not satisfaction and not relief. Something quieter. The specific recognition of someone who had spent a long time working in conditions where no one was watching and had not expected anyone to be watching now. The framework gap, he said. It affects outer rim operators the most. They run the mixes, the variance profiles, the system's past tolerance. They're designing fixes in the field every cycle, and none of it is getting back into the literature. I know, Vareth said. The proposal I have is a collection pipeline, a way to systematically capture that data and route it into the validation framework. Vareth looked up from the log. How long have you been working on it? Torin considered. It's about the 4th month of my first posting, when I fixed the same failure 3 times in 6 weeks and realized I was the only person who knew that failure mode existed. Vareth held that for a moment. Then she turned back to the log and wrote something. She wrote it under his name in the session performance record, in the field reserved for the evaluating director's assessment. She wrote 4 words. He's been teaching us. 3 weeks later, the proposal was submitted to the Consortium's methodology committee. It was 47 pages. It included a collection framework design, a proposed integration protocol, and 11 years of outer rim operational data that Torin had been documenting since his 2nd year in the field. Not because anyone had asked him to, but because he had understood, from the first time he fixed something that the literature had no solution for, that the solution should not stay only in his head. The committee review took 2 sessions. At the end of the 2nd session, the committee chair, a Veth senior architect, who had been with the consortium for 28 years, looked at the proposal documentation and said, to no one in particular, that this was the most substantive update to the framework's data foundation since the program's founding year. Nobody asked Torin what he thought of that. He was already back in his workspace, running the simulation confirmation on his fuel distribution redesign, feeding it the outer rim variance data that the framework had never had before. The simulation confirmed the design. It also flagged 3 additional failure modes that the existing literature had not documented. Torin noted them, opened a new file, and started writing.